Greeting guys. Welcome back. In this tutorial, I will guide you through the practice of setting up a robust image processing pipeline using Apache Kafka, Docker Compose, and we'll be using Python. And this pipeline will efficiently handle tasks such as background removal, background replacement, and image upscaling. So basically, the highlights are Apache Kafka, and we will be using Docker Compose, and then we will be using API service integration. So Apache Kafka distributed event streaming platform that enables real-time data pipelines and streaming applications. So Kafka will serve as a backbone for message brokering in our pipeline. And then Docker Compose is a tool for defining and running multi-container Docker application. So I will use Docker Compose to orchestrate the deployment of Kafka and its dependencies, and then ensuring a consistent isolated environment. And then we'll be seeing API services, which are custom API services which will perform image processing task, like background removal, which will remove the background of an image, and then background replacement service, which will replace the background of an image with predefined background. And then the third one is upscaling service, which will enhance the resolution of image. And basically the overview of this tutorial is we'll be setting up the Kafka with Docker Compose. So we will be creating a Docker Compose YML file to define and run Kafka and Zookeeper services. Zookeeper is essential for managing and coordinating Kafka brokers, and then developing API service, which we will implement the Python class for each image processing task, and we'll be using asynchronous programming to handle multiple requests concurrently. And then third, we will be integrating the Kafka with API services. So we will configure the Kafka brokers and consumers within our API services to facilitate communication between the components. And then fourth one is we will be processing the image, the final one. So where we will demonstrate how to process a list of image URLs through the pipelines and perform background removal, background replacement, and then upscaling in sequence. So let's dive in. So Apache Kafka is a distributed event streaming platform which is designed for building real-time data pipelines and streaming applications. So it enables the collection, processing, and storage, and also integration of data at scale, making it ideal for use cases such as real-time analytics, data ingestion, and event-driven architecture. So Kafka operates as a distributed publish subscribe messaging system, so which are allowing the application to produce and consume streams of records efficiently. So in this tutorial, we will explore how to set up and use the Apache Kafka within a Dockerized environment using Docker Compose. And then Docker Compose is a tool that simplifies the definition and management of multi-container Docker applications. So it allows you to define services, networks, and values in a single YML file, and streamlining the deployment and orchestration of complex application. So why we need Kafka and Docker Compose? First one is for the scalability and fault tolerance purpose. So Kafka's distributed architecture ensures that it can handle large volumes of data with high availability and fault tolerance. This is crucial for application that requires real-time data processing and reliability. The second one is simplified deployment. So Docker Compose simplifies the deployment of multi-container application by allowing you to define all components in a single configuration file. So this approach, which reduces the complexity of managing individual containers and their dependencies. And third one is isolation and portability. So Docker containers provide a consistent environment across different stages of development, testing, and production. So this ensures that the application behaves consistently regardless of where it is deployed. So basically, you see the architecture of Kafka-based image processing pipeline, which consists of the components like Kafka broker, Zookeeper, producer application, and then consumer application, and then processing services. So basically, Kafka broker, which manages the storage and retrieval of messages. So it ensures that messages are delivered to consumers and maintains the order of message within a topic. And then Zookeeper, which coordinates and manages the Kafka brokers. So it handles tasks such as leader election and configuration management, ensuring the Kafka cluster operates smoothly. And then a producer application, which sends the message to Kafka topic. So in our case, it will send image URLs to be processed. And then consumer application which receives the message from Kafka topic, it will process the images by performing the task like background removal, background replacement, upscaling. And then finally processing service. So these are like service API services that perform like specific image processing task. So they are invoked by the consumer application to process the images as per the requirements. Let's start by like creating an empty project. Okay, so from here we will be need to just structure our project. So first of all we need a folder for like API services, for example, and then we need a folder for Docker files where we will put up our API service Docker image and then Docker file and then Docker compose file. And then we need a pipeline folder where we will be defining our service like background removal, replacement, and then upscaling service. And then we will be having our main processing pipeline class, which will call all these services using Kafka. And then we should have a static folder where we can have our initial images and also to like to have our processed images stored. We will have it so where we can define custom functions. So let's start by like defining our base class service. How to do that? So inside our pipeline we create a base service, and I have already a base class, so it will serve as a abstract base class that will define a common interface for all the image processing service that we will gonna create. And then it will provide a logger for consistent logging across all the services as well. So if you see here. So and then now create a background removal service. So basically let me create a new file name which is for bg removal service. So import the packages which are necessary. So once done, let's define the class. Okay, here we will be defining a function process. So where it will take image URLs as an input, and then it will output the response which is returned from our third-party image service. So as I said, we will be using Fal AI for this purpose, and if you are really would like to consider other services or third parties, do not hesitate to add your services here. Okay, so now let's try to call the Fal AI client by submitting this image to ask for like background removal. So we can use a we can do it with try Fal client. We will just try to submit the model name and then arguments. Okay, so here the model name is for to remove the background. See, like asynchronously submits the image processing request and handles the events and results. We'll log the events and results for monitoring and debugging purpose. So we have to try this. Otherwise, we need to like build an exception block. So if it's the case, then we will return nothing. Otherwise, the final result will be sent. Next service that we're gonna develop is like a background replacement service, which will facilitate the replacement of background of an image. Let's implement the process method for that. So to do that, let me create the file. Now it will be replace service. We're doing the same thing. Import necessary libraries and define the background replacement class and define the process function, and then we have to provide the model name that we're going to use for this service as well the arguments that we will send to like replace the image. For example, the original image, the image that we want to be set in the background. And then what we have to do is we have to do the same thing as we have done for the background removal. So we have to call the asynchronously submit this image processing request with parameters like reference image URL and optional prompts, and then log the event and the results to provide the real-time updates on the processing status. Yeah, so the same thing that we have used so far here in our remote service. You can, for sure, you can optimize this code to like put all these common things in a file, and we can call the function separately for each service. Would be the better optimization that need to be done in the code base. And then you're ready to like define the upscaling service. So totally we will be using 3 services. Let me define the upscale service. The same way goes, for example, importing the necessary libraries, and then I have to define the class, and then we should have the process method. So it will be having the image URL and the model name, and define the model name and the arguments. So these are the arguments, or I mean the parameters, I mean model name that you saw, or like really customizable based on the client use. And then we will be calling the synchronous summit and adding some logging functionalities. So basically upscaling, which will performs the upscaling of image to higher resolution. So we have implemented the process method to interact with the Fally AI platform for image upscaling, and then asynchronously submit image processing request with parameters like scale factors and model types. And then we will log the events and results to monitor the upscaling process. And then we will include the error handling to like manage exceptions during the upscaling process. So basically in this code we have added asynchronous processing, and we have introduced like modular design for our service, and then also we have added error handling. So that's it for upscaling service. Let's define the main processing pipeline. So the main orchestrator of for the entire pipeline is like responsible for like managing the task and integrating with services, integrating it with Kafka. So let me define this file inside pipeline, which is processing pipeline sample. So basically in this file we will be saying like service flow. We will be starting the processing. This method is like invoked with a list of like image URL to be processed, and the images are like queued for like processing. And then we will be using background removal for each image, and then the background removal service that we have developed earlier, which will be called, and to remove the background from the image, and then the result is sent to Kafka. And the third is like background replacement. So after the background is removed, the background replacement service is called to like replace the background with a predefined background image. So we will put this predefined image in our static file later. And then upscale service, which will increase the resolution of the processed image. The final image is saved in. So let's like define the image processing pipeline that orchestrates the sequence of tasks on image, including like background removal, background replacement, and image upscaling. So it will call the services that we have created earlier here. And then it uses the synchronous programming and integrates with Kafka for like messaging to like signal the start and end of different processing steps. So the code like also handles like request to external services, and in an asynchronous way, and adding the request each time in the queue, and also logging for monitoring the pipeline's activities. So let's import the models that we essentially need. So let's explain, I define these functions later. So as you see, we need Kafka. So we have to define our requirement.txt. I have already the ID here. So we have to do pip install requirement.txt before try to run the pipeline. I have added like file client that we are using, that we have used, and then Kafka Python, and then we will be using other. So let's define our constant here. So just the link to the background image. Now we are good to implement the pipeline. Add the logging config, and then define the main class, which is responsible for like handling the processing of image. What it will do is it will initialize the image processing service with 3 services that we saw earlier, and it will set the maximum number of concurrent requests to 5. So we will see how it will be useful in the later stage. And then we will be initializing a Kafka producer for sending the messages to like Kafka topics, and then initializes an image queue using queue to manage the images that need the processing. And let's define the start processing function. Okay. So this method which starts the image processing by sending a Kafka message and adding the image URLs to the queue for processing, and then sends a Kafka message to the image processing start topic, notify the start of the processing, and then adds the provided image URL to the queue for processing to like start the asynchronous image processing in the background by calling processing images. Now define the process images. It handles processing of images concurrently with a concurrency limit, and this method which processes the images asynchronously as well. So it limits the number of concurrent tasks to like maximum concurrent request, and it uses the asyncio gather the multiple tasks concurrently and waits for them to like finish before starting the next batch. Now let's define the main. So this is the core method for like processing each image. It performs like background removal, replacement, and then upscaling, and saves the processed image at the end. So let's create this function. Here the image undergoes the background removal, and Kafka message is sent here to indicate the start of this step, like background removal start, for example here, and the processed image is saved locally. So from here, if you see, so once we got our response from calling the API, so we have to just get this base64 string, and then we will be calling this function get valid file name. For example, we have already defined this function here, get valid file name, generates the save file name from the URL. For example, it extracts the file name from the URL using URL parse, as you see here, and ensures that the file name doesn't exceed the maximum length 255 character. So once we have our safe URL, we can save it to the static folder. After background removal, the image must undergo background replacement and upscaling. So the background of the image is replaced using predefined background image. You see here, as we have already declared this in constant file, and then the image is upscaled. So if you see here, like after each of this processing, we are just saving the file in the static folder, which will help us finally to see like what output that we got, I mean what image that we got once after each step in our image processing pipeline. So the final step is like upscaling. The image is upscaled using upscale service. We just send the image that we got from the previous step, background replace step, and then we are sending this message for to upscale it. So after all processing steps, the final image is saved, and Kafka message is sent to indicate the completion. So to do that, we are just logging it as like we are at the end of the processing, and also we are sending the Kafka message indicating the image processing has finished. So basically, if you see the processing pipeline, it takes the list of image URLs and process them asynchronously in batches and perform background removal, background replacement, and upscaling. So each step in the process, like background removal, replacement, upscaling, triggers the message to the Kafka topics. See here, 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 and here. And then enabling the monitoring of the processing status. The pipeline supports like concurrent process of images with a configurable concurrency limit, as you see here. And then processed images are saved locally on the server, and the logging is done throughout the process. For tracking each step, we are saving the images. And the next step is like we have to develop a POST API application which provides an endpoint which is using process image, where the client can submit a list of image URLs for processing. So let's create a Python file here, name it as app.py, and import the necessary libraries. Create a simple class with a list of images. Let's get necessary variables for first API, and then we'll be calling the processing pipeline as well, and save it in the pipeline variable. So once we're done, the API endpoint. So it defines a post endpoint at like process images, and then an asynchronous function that like handles incoming request to this endpoint. It takes a parameter request type image URL request, which is the list of images that we saw here, list of string, for example, and ensuring that the incoming data adheres to the defined model. So inside this function, if you see, we are getting the image URLs by unpacking the requests, and then we will initiate the image processing pipeline with the provided URL. And finally, we will be returning a JSON indicating the processing has been started, and then it just lets us to know we can check Kafka for event streaming. So upon receiving a request, the application starts the processing pipeline and serves the static files, running the application using Docker. So to save the files inside the Docker directory, so we are putting like app static. Let's create a Docker file. So basically the base image for our Docker container is Python 3.8 Slim image. So which is light version of Python 3.8. Starting with a Slim image helps in like keeping the final image size smaller. And then we have to set up our working directory. So basically this line sets the working directory inside the container to app. Any subsequent commands like copy, run, or etc. will be executed in this directory. So if the directory doesn't exist, Docker will create it. So this command copies all the content from the current directory to the host machine to the app directory in the container. And so this includes our application code, configuration files, and any other necessary files. So this command which will install all the Python packages listed in the requirement.txt as we have defined earlier here. So it assumes that document.txt is among the file which is copied into the app directory. It will install all the necessary libraries which are required by our application. And then this command specifies to run when the container starts. Here it runs with UVCon, and which is an ASGI server for Python web application. So the argument specifies API app here. This points to the app instance in the API app here. This makes the application accessible on all the network interfaces. So this allows the application to listen on port 5000. So this Docker file is used to containerize our first API application. It just specifies the base Python image, setting up the working directory, copying the application code, installing all the necessary dependencies, and defining the command to run the application. And it ensures that first API app can run consistently across different environment. So containerizing the application with Docker, which provides benefits like environment consistency, scalability, and ease of deployment. So now let's create Docker Compose YAML file, which is used to like set up a multi-container environment, which is facilitate an image processing pipeline service that can leverage Apache Kafka for messaging, and then we'll be using Zookeeper, and then we will be also running the application inside this, the Docker that we have created here. So for to do that, let's create Docker Compose file. So this specifies the version of the Docker Compose file format being used. So version 3.7 offers a balance between like features and compatibility, so supporting advanced configurations like health checks and specific network options. And let's define our services. Basically, Apache Kafka, which relies on Apache Zookeeper for distributed coordination, like managing the configuration and leader election among Kafka broker, as we said. In the configuration, we will be using the latest version of the Confluent Zookeeper image, ensuring that we are having like up-to-date features and security patches. And we should just specify the platform as like ARM64 as an architecture to ensure the compatibility with the host system that we will be running this container with. And then container name, for example, here we have mentioned Zookeeper. And then we will be keeping the environment variable like Zookeeper client port, which is 2181. I mean the default port for like Zookeeper client connection. And then port map. So match the port 2181 to the container 2181 on the host, and then allowing the external services to communicate with Zookeeper. and then network which connects the Zookeeper services to the Kafka network for internal communication with Kafka. So now define the service Kafka, and it acts as a message broker handling the publishing and subscribing of messages between the producer and consumers in the image processing pipeline. The configuration details like image, the latest version of Confluent Kafka image and the platform, and then container image as Kafka. And in environment variable, Kafka advertised listener, which just defines how Kafka advertises its address. For internal communication with the Docker network, we use inside Kafka with this port, and for outside Kafka, we used for external communication from the host machine. And then Kafka listener here. It binds the Kafka to a specific network interfaces and ports. And inside Kafka, this port, it's just listen on all interfaces for internal communication. And outside Kafka, here it listens on all the interfaces for external communication. Then we'll be having a Kafka listener security protocol. It maps the listener names to security protocols, both set to plain text for simplicity in the development environment. And Kafka internal broker listener name, which just specifies inside Kafka for interbroker communication. And Kafka offset topic replication factor, which just sets the replication factor for the offset topic to 1, which is suitable for a single node setup. And then Kafka Zookeeper Connect, which points to the Zookeeper services at Zookeeper 2181 for coordination. And we'll be having volume, just mounts the host directory, which is data Kafka, to variable lib Kafka data in the container to persist the Kafka data, and then depends on to ensure the Kafka service starts after the Zookeeper service that we have defined here. And then network, which just connects to the Kafka network for internal communication. And then finally health check, which regularly checks the health of the Kafka broker by running Kafka broker API versions here, if you see, against the Kafka 9093 every 60 seconds. So retrying up to like 5 times upon failure. So finally defining our image processing service. So this service represents the custom image processing application that processes images and communicates with the Kafka broker for message handling. So basically in the configuration details, if you see build with a context, specifies the build context as the parent directory dot dot, indicating where the Docker should look for the files needed to build the image. And then we'll be having Docker file, which will points to the Docker file within the build context, so which contains the instruction to build the Docker image for the service. And then we'll be having the ports, which maps the port 5000 of the container to port 5000 on the host. So allowing external access to the service API or web interface, and also depends on Kafka, which ensures that the image processing service starts only after the Kafka service is up and healthy. So condition here which specifies the service healthy, which meaning that the image processing service will wait until the Kafka passes its health check before starting. And then environment here is like Kafka broker, which sets the environment variable as Kafka 9093, which is the internal broker address, so that the image processing service will communicate with. So finally network, which is Kafka network, which connects the service to the Kafka network, facilitating the communication with Kafka and Zookeeper. So finally, we define our custom Docker network name, Kafka network, to facilitate the communication between the service. And we have driver here, which specify the network driver as bridge, so which is the default network driver in the Docker. So this driver creates a private internal network on the host and allowing the container to communicate with each other while isolating them from external networks. So this is our complete Docker Compose YML, which helps in service isolation and management. So where each components like Zookeeper, Kafka, and image processing application is encapsulated in its own container, promoting like modularity and ease of management. And then it allows like inter-service communication by connecting all the services to the Kafka network. They can seamlessly communicate using names as host name, and then simplifying the network configuration. It just handles the dependencies using depends on directives, which ensures that service starts in the correct order, and the health check conditions are guaranteed that a service only starts when its dependencies are fully operational. Regarding the configuration management, environment variables are like used to like configure services dynamically, allowing for like flexibility and also easier adjustment without like modifying the underlying code. And then the Kafka service uses a volume to persist the data, ensuring the message logs are like retained across container restart. So by leveraging this Docker Compose, this setup like provides a reproducible and scalable environment for developing, testing, and deploying the image processing application with its associated messaging infrastructure. Test our API. So for to do that, let's create a just we can test our API using a Python file from here. Once after we launch our API services. So let me name this as test API calls. Import the request library and now define the URL as we will be launching the endpoint with this or using localhost. And then the payload, it is the dictionary which containing the data to be sent in post request. It has a single key which is images, and then get the response from the API call. So this will send a post request to the specified URL as we mentioned earlier with the payload dictionary, which is in the JSON formatted string, and which just sets the content type header to like application JSON. And this is a convenient way to send JSON data in post request using request library. And then we will be printing the response. So this script basically sends a post request to the process image endpoint of locally running a fast API server and providing a list containing image URLs in JSON format. And the server is expected to process the provided image URLs and return the response indicating like the status of processing. And also we will be printing out HTTP status code and JSON responses from the server so that we can verify the request was successful or not, and we can leave any messages or data which is returned by the server. So now we're done with all the script. So now we will be adding the readme to this project. So let me come back with the full PyProject config and readme. So now we are ready. Here is our readme. Whether we can run the application directly using this command, or we can, so for to run this command, make sure that your Kafka broker is running in parallel. Otherwise, we can start the application using Docker Compose so that like that every service is up and running, like Kafka, Zookeeper, so that we can launch the application successfully. For to do that, you can Docker build first. Otherwise, you can do Docker Compose of build. So let's build our image. So once you build your image, you can just run your application by launching the Docker container associated with this image. Or otherwise, you can easily just do a Docker Compose run. So what it will do is it will automatically start all the services which are necessary and launch your application as well. And then we can use the Python script that we have created for to test the API using the post request. We can just call this Python file. So once we called, we can see the log side by side. So now we can run Docker Compose using a specific Docker Compose YAML file here. For to do that, let's do Docker. The file path would be like Docker Compose in our case, and do up. So if you are like running this for first time, what it will do is it will try to pull the image, I mean Kafka, Zookeeper image from Confluent, Let me zoom a little bit. So for my case, like I have already pulled this image. For example, if I go here, let me. So I have these images already available in my local machine. I have already pulled it. And if you see the container, like we just run it with Docker Compose, so it have launched like Kafka, which is running, and also Zookeeper, it's running as well. And our image processing service is up to run. If you see, the build have already happened for image processing pipeline, and we are ready to like launch our application. I mean, we can ready to test our application using the Python test script that we have created earlier. You see, the application is launched here. We can use another terminal where we can launch the Python script for test, and we can see the log side by side here in the left side terminal. So let's launch our test script. For the first time, we will be testing with single image in our payload. We will be sending this to the Apache API endpoint, and we will try to like display the processed image at each step. And if you see, the Kafka event streaming have been started, and this is the first processed image with the background removal. And let's search for the second image where the image will be replaced with the background image that we have defined in the script. So here we have this image. Let's open it. So if you see here, yeah, the background is replaced. And the third step is like upscaling. It's I think it's have already been done. Let me search the log upscale. Yeah. So now we have the image here. Let me open it. So this is the output of our image processing pipeline where the image have undergone like upscaling. So this is how we can test like our image processing pipeline easily by using a Docker Compose run. So let's check. Let's test with more images. Like send 5 image URLs to the first API endpoint and display the processing image at each step. Also, if you remember, we have added like concurrency in our programming. So let's run the script, and so images are like processed asynchronously, allowing the server to like handle multiple processing tasks concurrently. However, to like manage the system resources effectively and preventing the overloading, we have implemented a mechanism to process the images in batch. So if more than 5 images are like received in a single request, the application processes them in batches of 5. So once the first batch is processed, the application processes to the next batch and continuing this cycle until all the images are processed. Basically, we have implemented it with asynchronous method in our Python using a async IO library to handle like image processing tasks asynchronously. So this application allows the server to initiate multiple image processing tasks without waiting for each to complete before starting the next. So thereby like it improves the efficiency and the responsiveness of the pipeline. And also like we have introduced batch processing to prevent like resource exhaustion and then manage the load effectively. So the application process images in batch of 5. And why we are just introducing these approaches, it's for like resource management and scalability purpose, and also for the responsiveness purpose. So by limiting the number of like concurrent processes images to 5, the application can avoid overwhelming the system resources. And then this batch mechanism which allows the application to handle large number of images effectively by controlling the workload and preventing the bottleneck. And asynchronous processing, which ensures that the application remains responsive to new requests and even like while processing multiple images inside. And we can just configure our batch size so easily, and we have our complete error handling mechanism which is implemented, so it's easy to monitor as well using the log. for the image and the messages that we get in each stage of our pipeline. So if you see the pipeline is in progress, okay. So in parallel, we can also see what are the images that it have been outputted in like each stage. For that, we have to go to like Docker. So before we go and see our processed images, let's check the topics in our Kafka broker. So the command you see here in the screen, Docker execute IT, Kafka topics, Bootstrap server with Kafka 9092 list is used to like interact with a running Kafka container and list all the topics available in the Kafka broker. So when executed, it first accesses the Kafka container named Kafka in our case using Docker execute command with the flag which is IT like you see, which allows for an interactive terminal session with the container. So the command then calls Kafka's Kafka topic tool, which is used for like managing topics in the Kafka cluster. So by specifying the Bootstrap server Kafka 9092, the command connects to the Kafka broker located at Kafka 9092. So finally, the list flag, which tells the Kafka to list all the available topics in the Kafka broker. So this command is useful when you want to like verify or inspect. So you mostly run this command like when you need to check the topics in your Kafka cluster, especially after configuring Kafka, like adding new topics or troubleshooting any issues related to the topic management. So it's common step for after like deploying Kafka in the Docker container to confirm that the broker is running correctly and that like the expected topics have been created. So regarding the scalability or like designing a high throughput image processing pipeline, you may consider like horizontal scaling where you can have your Kafka cluster deployed with multiple brokers to handle higher message throughput, use a replication factor for fault tolerance and partition topics to distribute load across brokers. And you can use application instance like you can use an orchestrator like Kubernetes or Docker Swarm to deploy multiple instances of the application. So these instances can subscribe to Kafka topics with consumer groups, distributing the message processing efficiently. And regarding the cloud deployment, you can use managed Kafka, use like cloud managed Kafka services like AWS MSK or Azure Event Hub or Confluent Cloud to reduce the operational overhead and ensure the reliability. We can also use serverless compute. We can migrate the processing service to serverless platform like AWS Lambda or like Google Cloud Functions to enable auto scaling based on like message value. And also we can make use of load balancer, deploy a load balancer in front of the application API, which is with AWS ALB or GCP load balancer to efficiently manage and route the incoming requests. And regarding the optimizing the message processing pipeline, we have already implemented the batch processing. We can implement batch processing for Kafka consumer to reduce the overhead of frequent input-output operations and improve the throughput. And also we can do message filtering. We can use Kafka streams or case KSQL DB to filter or pre-process the messages at the broker level before they reach the consumer. And we can also consider priority queue, like implement multiple Kafka topics with different priorities for time sensitive or critical tasks to ensure the efficient processing. And regarding the monitoring and auto scaling, we can make use of the tools like Prometheus or Grafana or cloud native solutions like AWS CloudWatch to track system health, monitor Kafka message lag, and broker performance. And we can configure auto scaling policies for both Kafka brokers and application instances based on CPU usage, memory utilization, and Kafka consumer lag. And regarding the data persistent, we can make use of data lakes, like use cloud-based storage solutions, AWS S3, GCP storage to like archive the processed images or messages for long-term retention and analytics. And also regarding the database scaling for metadata storage, migrate to distributed database like Amazon Aurora, MongoDB or like Google Cloud Spanner to enable like horizontal scalability. And regarding the workflow orchestration for managing complex pipeline, integrate a workflow orchestrator like Apache Airflow, Prefect, or Argo Workflow. These tools can handle like task dependencies, retries, and scheduling for streamlined processing. So I hope this may help to like add or integrate the scalable design in your image processing pipeline or any other Kafka-based event-driven pipeline. Let's go and see the processed images. Let's open the static folder here and go to processed folder. Let's import all the processed images to our local machine. So in this folder, we will be having each input image undergoes 3 distinct processing stage. So we will be having 3 corresponding output for each image. For example, here the one is background removed and another one is with background replaced and another one is with upscaled image. Let's open other images as well to see quickly. Let's compare the image side by side. The image which have undergone upscaling with the image from the earlier process. So if you see. So in this tutorial, we have explored how Apache Kafka serves as a robust platform for building real-time, event-driven application. By leveraging Kafka's distributed architecture, we have demonstrated how to efficiently handle high volume of streaming data, ensuring like scalability, fault tolerance, and also low latency processing. So this foundational understanding equip you to implement Kafka in various scenarios in real-time analytics, log execution, and event sourcing, and thereby like enhance the responsiveness and resilience of your application. I hope you find this tutorial helpful, and I have provided the link to all the resources that we have used in this tutorial in the description below. See you all in our next video, and until then, this is Abhumya. Bye for now. Thanks for watching.